In this lecture, I'm going to introduce you to this section of the course, tell you what it's all about, and also outline what you will learn. This section is all about financial basics. Now, a lot of you joined this course because you want to learn about time series analysis and machine learning with financial data. But the first step, before you do any of that, is to answer the question, what is financial data in the first place? Usually, most lay people have a general understanding of this. They know about stock prices. They know about general ideas like buy low and sell high. They know that what you would ideally like to do is to purchase some shares of a stock today, and at some later date, when the stock price has risen, to sell that stock for more than they bought it for, thus making a profit. Of course, there exist very many stocks in the world, and you don't want to purchase them all. Some will succeed, and some will fail. Perhaps you have some knowledge about an industry or about a company, and you believe that the stock price in that industry or that company will go up. And therefore, you would like to purchase those stocks in hopes of making a profit. Of course, whether or not a stock price will go up is not guaranteed. You are always making a gamble. Thus, the language we use to talk about stock prices is probability. In fact, a lot of the theory behind probability was founded on gambling. In this section, we're going to start from the very basics. Where do you get financial data? In typical machine learning, we are accustomed to having standardized datasets like MNIST and ImageNet. But this doesn't make sense for financial data. There's no such thing as a standard dataset. If you want to predict the return of a stock over the next month, then the stock price from the 1950s is not going to be very helpful. So, in the real world, often what you are looking for is the most recent data. For the purpose of this course, we will be working with fixed datasets, but you want to be aware of the fact that, in practice, your data isn't going to be some static CSV file. Next, we will talk about what financial data looks like. In this course, we will be focused on what is called technical analysis, which uses historical stock prices and volume information. This is opposed to fundamental analysis, which uses information that is more like what an accountant would look at, such as a business's financial statements. Technical analysis is what most of us think of when we imagine doing machine learning on financial data. We have a set of time series which represent historical stock prices, and we would like to use machine learning models to forecast future stock prices or something like that. Next, we'll look at a quantity called the stock return. Roughly speaking, the return is how much the stock goes up or down in a given period. This is a very important quantity, as you'll see throughout the course. Most of the modeling and the calculations we do will be focused around the return rather than the price. So, what is this modeling that we will do? One important task in finance is understanding the distribution of returns. If you understand what probability distribution your returns come from, then you can calculate things like their expected value and their volatility. Most often, people assume returns are normally distributed, but as you'll see, this is not necessarily the case. So, what kind of modeling will we do? First, we're going to look at a type of plot called the QQ plot, which is a graphical method of determining whether or not our data comes from a certain distribution. We'll use quantitative methods to do this as well, which in statistics is called hypothesis testing. Hypothesis testing is an important concept in this course, and it will appear again in future sections. We'll also look at confidence intervals, as well as statistical measurements, such as skewness, kurtosis, correlation, and covariance. These are all important in understanding the behavior of stock prices. Next, we'll have our first mini introduction to machine learning models. We'll look at a model called the Gaussian mixture and show why this might be a good model for modeling stock returns. Next, we'll look at an important feature of stock returns called volatility clustering. This shows us that the behavior of a stock return changes over time, and that how it changes is related to how it has changed recently. This helps us to have some predictability in the behavior of stock returns. Finally, we will look at a simple example on how to simulate the evolution of a stock price. Simulation is also a very important task in finance because it allows you to model all the possible futures of a stock. Simulation can be used for things like calculating the expected price of a stock in the future, as well as the confidence bounds on that prediction. In addition, simulation can be used to backtest any strategies you have come up with for trading stocks.